in order for Pakistani businesses to use cost-effective giant gears. Their small workshops use traditional sand casting techniques to manufacture them. Although this method is slower, combined with simple mechanical equipment, they can still produce precisely structured giant gears. Given the massive size of the gears, traditional sandboxes can no longer hold them. Therefore, the craftsmen dig a large round pit in the ground to serve as a casting mold. Once the pit is dug, the craftsmen lay down a layer of sand with high adhesiveness and excellent plasticity, which is ideal for making large gear molds. Using a square pipe and a level, the experienced craftsmen create a level base. After laying the sand, they poke many small holes in the bottom and inject carbon dioxide to quickly harden the sand, creating a solid base for the casting. When the base is hardened, the craftsmen place a sun-shaped gear mold in the center of the casting pit and cover it with the top layer of the mold. At this point, the main shape of the gear is roughly formed. They then begin creating the teeth of the gear. This process is relatively simple. They fill the mold with sand and compact it, then inject carbon dioxide to harden the sand, forming the precise tooth mold. These gear teeth are carefully placed in the positioning slots, which ensure that the teeth are accurately aligned. The casting of the giant gear requires 16 tooth molds, which is quite a challenge for the workers' backs. Once all the tooth molds are in place, the craftsmen fill the gaps with sand to seal the mold. They backfill the casting pit with surrounding soil to support and stabilize the gear mold. To further enhance the stability of the mold, the craftsmen compact the surrounding soil. They then lay a layer of sand on top, shaping it into a square platform. Since the mold consists of 2 layers, they use iron frames to support the upper mold. To ensure stability, they place steel rods inside the mold to prevent it from cracking under the high temperature of the molten iron. Red bricks are used to create vent holes and pouring channels, allowing hot gases to escape during casting, which reduces the risk of mold cracking. Once the iron frames are filled and compacted with sand, the upper mold is complete. The craftsmen use a crane to lift the model out of the casting pit and remove the wooden parts of the gear mold, leaving the basic gear shape. Next, a cylindrical sand core is placed in the center of the gear mold to form the gear's axle hole. Finally, they use the crane to carefully lower the upper mold back into place, filling any gaps with sand to prevent the molten iron from leaking and apply pressure to stabilize the mold during casting. Once all these preparations are completed, the large casting mold is ready for the molten iron. Meanwhile, in another part of the workshop, the craftsmen are selecting metal scrap for melting. These materials come from discarded machinery, scrapped vehicles, and other metal waste. They feed these scraps into a large induction furnace, where the high heat melts them into molten iron within about 2 hours. Using a hydraulic system, the furnace is tilted to pour off the molten iron, removing impurities in the process. The clean molten iron is then transferred to a large ladle, which can hold up to 3 tons of iron, highlighting the enormous scale of the gear being cast. Once the ladle is filled, it is carefully transported to the casting mold. As the molten iron slowly flows into the mold, the scene becomes fiery and spectacular. The craftsmen closely monitor the flow to ensure the mold is evenly filled. After the mold is fully filled, the casting must cool naturally for 24 hours. This step is critical to ensure the structural integrity of the gear. Once cooled, the formed gear is lifted out of the sand mold using the crane. The casting is then carefully cleaned of any remaining sand, especially in the deep grooves of the gear. Regular cleaning methods are ineffective on these hardened sand clumps. So the craftsman must use high-powered electric hammers to break them apart. After removing all the sand, the gear's clean metal surface is revealed. Though the gear is now formed, it is not yet ready for use, as there are still excess materials, like sprues, from the casting process. These are precisely cut away using acetylene torches to achieve the final shape. While the gear has taken shape, it remains a rough casting and needs further processing. The gear is slowly lifted into the workshop with a crane and securely mounted on a lathe. Once everything is ready, the lathe is started and the rough machining begins. The main goal at this stage is to quickly remove excess material and form the general outline of the gear. The craftsmen, with their wealth of experience, control the lathe to efficiently shape the gear. After rough machining, the gear enters the fine machining stage, where every touch of the cutting tool must be precise. The cutting depth is significantly reduced, and the speed is slower and more controlled to ensure every detail meets the required precision. Once the surface machining is complete, the craftsmen mark the surface of the gear teeth with paint and carefully set the gear model in place. They then use a pencil to outline the areas that need further machining. After securing the gear back on the lathe, the cutting tool moves along the pre-marked lines, slowly cutting out each tooth. The craftsmen closely monitor the wear on the cutting tool to ensure consistency throughout the process. After 48 hours of continuous work, the giant gear is finally completed, showcasing the impressive craftsmanship of the Pakistani artisans. This process not only demonstrates the high skill and precision of Pakistani craftsmen, but also shows their ability to produce large mechanical parts that meet strict industrial standards, even with limited resources. It's truly impressive. Their expertise and dedication in the field of mechanical manufacturing are clearly evident. What do you think of the skills and craftsmanship of these Pakistani artisans?